use caches. So the next thing is that how are you going to measure that, oh, I decided to use caches, but has it made a difference? So one way is that your users hopefully will come back and tell you, wow, your application is working much better. What have you done? Have you added servers? Yeah, some new technology, but it could just be as simple that on the existing servers itself, you just added one more application, which is a remote cache, and your code is using it now in a good way. Because at least in my experience, I've seen that most app servers have a lot of free space for RAM and CPU cycles, and a good cache would not use more than 1 or 2% of the CPU. So you can generally even leverage, make use of your existing servers and just put 1 or 2 more instances of caches running on them, and then suitably edit your code to use them. Of course, in some very big applications, like the 3DS system, we used to have caches running on special cache servers, and we had, for some specific requirements, we had some internal in the same JVM caches, small caches of like 100 MB or so, and on the same system for speed, we should have local caches. Local means on the same box caches as well. Because there's no doubt that when you hit the local host, it's much faster than if you hit something else on your same VLAN. So the ways to test is the best way, I would say, is through Selenium or JMeter, unit test cases, and things like that. Though you could always do this with a manual clock with cache and without cache. So before you measure it, you need to first plan out how you're going to be using your cache. And you need to decide, like I said, what to cache. Then you need to plan your database file system so that if it's already a running application, you might not need to do this. But if you're doing it afresh, then you definitely should plan it out that when you're going to hit your database, when you're going to hit your file system, when you're going to hit the cache. And like I said earlier, that you always have to have a backup plan. That if something is not there in the cache, you cannot rely on the cache. You have to have plan B, where you will go to get the item which is being requested. And then you need to prepare your code so that the code, like Hibernate code or the code of your web server would have some add-on which will allow it to use caches. You would have to prepare that XML files or the conf file so that it uses caches. And then in some places where you're calculating some code like an encrypted value, you would start storing it in the cache and make a few changes and then measure again, then again make a few changes and measure it again. So on this next slide, I have some sample data that this was used using Selenium and JMeter, where we were hitting an application with some 220 requests. So this is after a restart that you can see that it takes a little bit more time while the JVM gets warmed up and all our code gets initialized, and then we see that it's quite high. And the time, which is the red bars, are the time it took to service the requests, which are represented by the blue bars over here. And down here you can see that with cache, the initial time was a few seconds higher for the same 220 requests, but as time goes by, the time to serve keeps coming down, and then it settles down again in one approximate average time. There are always some variations because of network, and the system might be doing something else, or there might be something new which has to be cached. So it will be like a normal request. Plus, it has to be entered into the cache so that it is returned from the cache next time. So this is some data around that. So this is the URL where you can get the code which I showed you the screen for, and if we have time, we can even see the sample application working. And I've also given a link of Apache modc because that's one of the web services used quite a bit. So I show you of running the cache server now. I have a command prompt open. This -vv is for extra plugging, but we don't want to do that generally. I'm going to be starting 2 remote caches now. So the server is now loading. It takes a few seconds. And now it's telling you that it's listening on port 11211. And the second instance is starting on 11212. It started now. So now I'm going to open another command prompt. And I'm going to telnet to test this. Now the telnet test session has started. So I'm just going to test if I can read a particular value. And now I'm going to set it. I've kept these commands ready so I can quickly now it's stored the value. And if I say get, it will return the value. Now we'll move to the application, which is a much better way to do this. So I just have a small little batch file to start it. And you can see on the startup screen how it is connecting to the remote caches, which are command line parameters. And now I can set a new key, give it some value, give it a TTL, set it. Now I can open up a new one, the same client in a new instance. So we have 2 instances of the same application connected to the same remote caches. And here I set a set. Now I'm going to do a get. And we see that we stored in the earlier instance comes here. Similarly, if we store with some key here and set it, now I'll go and request key B. The secret, of course, is that both your applications should know how to make the keys and what the common keys are. For example, in the application where I was working, we used to store in cache email templates. So like we had many customers and many banks as customers, and each bank had over 40 emails which could be sent to a customer. So instead of reading the email template from the database every time, we should keep it in a cache. And then there was a common format of the key depending on the customer ID and the event ID, what type of email we were sending to the customer. So there would be a particular key. For example, you would have bank, times, and then you would have email 1, and then this would be like dear customer name, and then some some contents which tells the customer what has happened, like you started a new account. And then you could like have a multi-line email, and then you could have URLs, etc., all in this template. And then so it's set into the cache by the first app server which requires this, and then other app servers which need it could just simply get it, and they would get the same, be like a big blob. It could be an image, it could be any amount of data which you have RAM for, you can store it in there. So this is a little test application to get you help you get started. You can get the from the link which I've provided. So let's go back to the PP station, and this is the link where you can get that code. And I'll be adding some more code after 7-8 days to the same location. So for some sensitive applications, a question can come that, how secure is the cache? That can somebody tap cache and get data which they're not supposed to see? So the answer to that is that the cache, at least the example which I showed you, is a Java application, and it has as much security as any other Java application running on your network does have. And the main thing is that, for a server, you need to restrict the users who can access it, who can take memory dumps, etc., to keep your application safe. So if they can take a memory dump of your main JBoss or your main application server, then they as well can even compromise your cache. And some caches like Varnish cache even have access control built into it, so that you can provide some information and you can tell the cache what resource is viewable by which user or which type of user. So Varnish is, I've not used it myself, but I've read that it has that capability also. So two parts of security. One part is how secure is the cache itself, and it's as secure as any other Java application in your network. And the second thing is that can a cache do part of your app server's work of holding